Welcome, my dear student, in our math program for secondary 3. Dear student, today we are taking new lesson in dynamic. What is the title? Relation between acceleration, velocity, and distance by using differentiation and integration. أعزائي طلبة وطلبات شهادة الثانوية العامة قسم رياضيات لغات، أهلا بكم. اليوم سوف نتطرق إلى درس جديد في الديناميكا، وهو استخدام التفاضل والتكامل في إيجاد العلاقة ما بين العجلة والسرعة والمسافة. أتمنى أن نوفق إن شاء الله في هذا الدرس بإذن الله. Dear student, relation between V0, V, A and S by using integration and differentiation. Look at in the opposite figure, look at the distance S, V velocity, A acceleration. What is the relation between V and S? Excellent student. ds over dt means the velocity. What is the relation between A and V? What is the A? Acceleration. We find acceleration by using derivative of the velocity. Acceleration is A, velocity V, A equal dv over dt, or derivative of velocity respect to time t. Then we use integration when we find S by using integration velocity respect to the time t. If we have velocity and we find the distance or the required the distance, we use the integration. Why? Because S equals integration of velocity respect to the time t. Remember, integration operation is opposite operation respect to differentiation operation. Why? Because A equal dv by dt or V equal ds over dt. When we find V and the given S, we use derivative S with respect to the time A t. Why? Because V equal ds over dt. But in this case, S equal integration V respect to time t. Then in this case, we use integration when the required is the distance. The distance is integration velocity respect to time t. Number 2, we use integration of acceleration respect to time t if the required is v. Then v integration a dt. Remember, don't forget, dear student, a is dv over dt, but in this case the required is v, final velocity. The given is a acceleration. We use integration. Then v equals integration a respect to time t. V is function of s, s function of t. Acceleration is dv over ds. By using integration, we use integration of left hand side a respect to ds equals integration of v dv. Dear student, remember the integration operation is opposite of differentiation operation. We have relation between acceleration, velocity, and distance s. Acceleration is dv over dt. When we find acceleration and the given is velocity, we use the derivative, the velocity respect to the time t. But if we have acceleration and the required is velocity, we use integration. What is the velocity? Is integration a respect to the time t. Remember, dear student, also s means the distance is acceleration of velocity respect to the time t. Dear student, look at the important rules. Acceleration A ds equals v dv. ADS, integration of ADS equals integration of v dv. But using integration of from v naught to v dv equals what? Integration from 0 to t a dt. Integration v dv equal integration a dt. Number 5, integration v dt equals integration ds. Example. Dear student, particle moves in straight line. The velocity is 1/20 multiply bracket contains 400 minus x square. Find the acceleration. Dear student, remember the velocity is function of x. X is a distance. Velocity is v. What is the required? Acceleration. In this case, we use derivative or integration. Find a at x equal 15. What is the a? Acceleration. We use integration or differentiation. Excellent student. A equal integration derivative of dv by dt. Look at the solution. V equals, this is the relation between v and x. Therefore, a is derivative dv by dx times dx over dt. Look at dx over dt means the velocity. Remember, acceleration is dv over dx by using, look at negative 1/10x. Then a acceleration equal v dv over dx 1/20 multiply 400 minus x square times negative 1/10x. Remember, dear student, a acceleration is equal v dv over dx. What is the velocity? Velocity is given equation equals 1/20 multiply bracket contains 400 minus x square. What is the dv over dx? Negative 1/10 times x. Then a becomes negative 1/200 times 400 minus x square inside bracket equals negative 105 a over 8 unit acceleration. Look at, dear student, another example. Look at when v equals 5/4 plus x meter per second. X at meter, find a when x equal 2 meter. Solution. V equals 5/4 plus x equals 5/4 plus x power negative 1 by derivative respect to s dv by ds negative 5 multiply bracket 4 plus x power negative 2 times 1 derivative of x. Then answer is negative 5/4 plus x inside bracket for all power 2 dv by ds at a equal v dv by ds by substitution about v equal 5 over 4 plus x multiply dv by ds is negative 5 over 4 plus x for all power 2. Remember, dear student, acceleration is v dv over ds. What you mean dv over ds? Derivative velocity respect to s. The velocity is v 5 over 4 plus x multiply dv over ds times negative 5 over 4 plus x for all power 2. Answer is acceleration negative 25 over 4 plus x for all power 3. By using x equals 2, then negative 25 over 216 is the value of acceleration when x equals 2. Dear student, this example is very important. Find acceleration and the given is v. After find dv by ds by using a equal v times dv by ds, acceleration is equal negative 25 over 216. Now we are translate to another example. If we have v squared equal 5 multiply bracket contains 9 minus x squared. Find acceleration A if v equals 0. Dear student, look at the solution. V squared equal 5 multiply 9 minus x squared. This equation of the velocity. By derivative respect to time t, then 2v dv by dx equals what? 5 multiply negative 2x. Remember, dear student, the equation is v squared equals 5 multiply bracket contains 9 minus x squared. This relation between velocity and x. What is the required? The required is acceleration. A. What is the acceleration? A is, remember, x and student, v dv over dx. Then by derivative both sides respect to the time t. The left hand side is 2v dv over dx. Right hand side becomes 5 multiply negative 2x. After that, 2v dv over dx is equal negative 10x. Then 2a equals negative 10x. Remember, v dv over dx is acceleration A. What is the A? In this case, negative 5x. Divided left hand side and right hand side by 2. Then acceleration is negative 5x. By v equals 0, x equals positive or negative 3 from the first equation. Then by using a, x equal 3, then a equals negative 15 meter per second square. A equal negative 3 is 15 meter per second square. We have two motion. The first is negative 15 when a equal negative 15 is retardation or deceleration, but when a times negative 3 equal 15 meter per second square is accelerated. Look at, dear student, another example. We have v equal 60 square minus 24. Find acceleration when v equals 72 meter per second. find A when V equal 30 meter per second. Also find displacement when T belongs to closed interval 1 to 4. Solution. Dear student, V equals 6T square minus 24. When V equals 72 meter per second, by substitution about V equals 72 to find the value of T. Then 6T square equals 96. T equals what? 4 seconds. In this case, when V equals 30 meter per second, by substitution, then 6T square equals 54, T equals 3 seconds. Acceleration equals dV by dt, 12T, at T equals 3, then acceleration is 36. Remember, dear student, when V equals 30, we find the value of T equals 3. We know that acceleration A is dV over dt. What do you mean dV over dt? Derivative of the velocity respect to the time t. Answer is 12t. We find acceleration when t equals 3 by using or substitution about t equals 3. Then acceleration is equal 36 meter per second square. When we find S, the distance or displacement from T1 to 4, we use integration of velocity respect to the time t. S equals integration of 1 from 1 to 4, finite. From 1 to 4, v dv dt. Why? Because we have equation of the velocity, and the required is distance or displacement. The given is velocity. The required is S. We use integration. Excellent, student. S equals integration from 1 to 4 v respect to time t. Therefore, by using integration of the velocity, what is the equation of the velocity? 6t squared minus 24. We use integration when t equals 1 up to 4. By integration, look at 6t squared. Integration is 2t power 3 minus 24t. Finite integration from 1 to 4 by using when t equals 4 and subtract when t equals 1. Then we find the answer is 2 times 64 minus 24 times 4, the first bracket, minus when t equals 1, second bracket, 2 minus 24 inside the bracket. Answer is 54 meter. This is the distance or displacement. Remember, dear student, when t from 1 to 4, the distance the particle covers is 54 meter. Dear student, we are translate to another example, very important. Particles start to move in a straight line from origin point with initial velocity of magnitude 8 meter per second and acceleration of motion after t second is given by the relation 3t minus 2. Find each of the velocity of particle and its displacement after 2 seconds from starting of motion. Remember, what is the required, dear student? The required is find the velocity of particle and its displacement after 2 seconds from the starting motion. Remember, starting motion v naught equals 0. Look at, dear student, when a equal 3t minus 2, v equals integration 3t minus 2. What is the v? 3 over 2 t squared minus 2t plus c. v naught equals 8 when t equals 0. Therefore, c by using t equals 0 and v naught equal 8, we find the constant c is 8. Then v equal 3 over 2 v squared minus 2t plus 8. v2 3 over 2 t squared minus 2t by using t equals 2. v2 equals 3 over 2 times 4 minus 2 times 2 plus 8. Answer is 10 meter per second. Since velocity is 3 over 2 v squared minus 2t plus 8, by using integration, look at the distant x, integration of 3 over 2 v squared minus 2t plus 8 respect to the time t. Answer is half v power 3 minus v squared plus 8v plus c dash equals 0 by using x equals 0 when t equals 0 to find c dash equals 0. The relation is half v power 3 minus v squared plus 8t. Find s when t equal 2 equal x times 2 is half t power 3 minus 2 power 2 plus 8 times 2. Answer is 16 meter. Dear student, now we are translate to important example. Particle moves in straight line. That algebraic of its velocity is given as function of time by the relation v equals 6t squared minus 24. Where v is measured in particle reaches 72 meter per second, then find the magnitude of acceleration of the particle when its velocity reaches 30 meter per second and the magnitude of displacement of the particle during t belongs to closed interval 1 to 4. Solution. Look at, dear student, v equals 6t squared minus 24. When the velocity of the particle reaches 72 meter per second, by substitution about v equals 72 to find the value of t. Therefore, 6t squared minus 24 equals 72. By using 6t squared equal 96, t squared equals 16, t equal positive or negative 4, but negative is refused. We use t equal 4 second. Remember, dear student, the velocity is equation or function of t. v equals 6t squared minus 24. When the velocity particle reaches 72 meter per second, find the value of t. By substitution about v equals 72, we calculate the time t squared equals 16, then t equals 4. After that, when the velocity of the particle reaches 30 meter per second, then by substitution about velocity equals 30 to find the value of t. Then 6t squared minus 24 equals 30, 6t squared equals 54, by divided by 6, t squared equals 9, therefore t equals 3. Acceleration dv respect to dt. We derivative the velocity respect to the time t. Remember, dear student, in this case the required is acceleration and we have velocity. the velocity. When find the acceleration, we use derivative of velocity respect to the time t. Why? Excellent student, because A, acceleration is derivative of velocity respect to the time t. A is equals 12t. T equals 36 meter per second square. Y? T equals 3. Then acceleration is 36 meter per second square. When we find S, we use integration v respect to time t from 1 to 4. S is 8 and integration from 1 to 4, v is bracket contains 60 squared minus 24 respect to time t. Therefore, integration is t 2t power 3 minus 24t from 1 to 4. Therefore, by using substitution about t equal 4 and t equals 1, answer is 54. Remember, dear student, when we find displacement and the given is velocity, we use integration. Why? Because S is integration of the velocity. The required is find S or displacement when t from 1 to 4. We find integration v respect to time t by substitution about v equal 60 squared minus 24 respect to time t. Then the integration is 2t power 3 minus 24t from 1 to 4, then S is 54 meter. Dear student, by the end of the lesson, we know that the relation between velocity, acceleration, and the time t. Remember, dear student, this relation is very important relation. I am very happy to spend such time with you. Goodbye.